I'm Aman. I work for Citibank, but everything I say here doesn't reflect the company, just kind of our experiences. I usually open with a joke, but we only have 20 minutes, so I don't think I'll be able to. But if I have time at the end, I'll tell it to you. It's not very good. It's just a little bit enjoyable. So last year sometime, we started doing some work with Node. We needed to do some interesting reverse proxying and exposing services, usual cases, but not going down a microservices route. We've expanded it since then, and we're trying to put together a take over the world sort of skunkworks project. So I'm a mobile architect. I love distributed systems. I come from a C++, Java, .NET, everything background. I try to reduce entropy, which is really hard in a big company. So we try to figure out how it works. I'm used to developing complicated and high throughput distributed systems, wonderfully decoupled, causing lots of problems, so lots of fun. I'm on Twitter. I usually use Twitter as my outlet valve, so not everything I say is serious. So I'm going to cover today why we chose Node, and a lot of this is kind of an echo of what's been said already. So it's not going to be anything revolutionary, but it's interesting for us. What we want to do with it and what we did with it is really what we're going to do. It's not so much about taking a service and making it ready, kind of a reverse proxy way. There's a little bit of that, but what's more interesting is the work we're going to be doing around it. Our first job is just kind of the focus of this. I gave this presentation with my team in Node Dublin earlier this year, or a variant of it. They couldn't be here today, so they say hi. All right, so Node is mainstream, kind of, since 0.4, but more so now. We're hearing about it more and more. You're seeing more and more people using it as the go-to systems language. And these are 3 bands, in case you don't know. The Black Keys, Coldplay, and Arcade Fire. One of them are rubbish, one of them are okay, one of them are awesome. So this is an interesting thing. So this is one of the guys on the team. He gave all the sort of funny captions. So this person is buying something and is standing in a queue saying, God, it's not moving. It's actually standing behind 2 mannequins, which is really annoying. So why did we pick Node? I really like the asynchronicity of it. That fits in very well with distributed systems and the world we're in now. If you see how systems architectures have evolved over the last certainly 3 years, if not 5 years, we're now massively distributed. All this talk about Docker, all this talk about VMs sitting in containers, that's leading it. Platforms, services, and clouds, that's all helping in this stuff. The other thing is we're seeing more and more people with JavaScript skills. So they can be full stack engineers, or they can be back-end engineers, or they can be front-end engineers. JavaScript is becoming the lingua franca. It's got a great community. I think Node is one of the more interesting communities I've seen come up. People are generally quite supportive. There's a lot happening in it. It's very active. And there's a solution for everything, pretty much. A couple of other things, not so much. The other thing is, because I kind of focus on mobile stuff, it's really handy for the sort of mobile protocols that are out there, be it messaging, be it web, other types of integrations. And because of Node plus asynchronicity plus newness plus JavaScript plus enthusiasm, you can turn solutions around really quickly. And there's kind of a rough idea why we did it. Now, inside work, beware of dog, staff only, it's the sign. Inside of work, it's actually approved. I was shocked about 18 months ago. We have, 300,000 people working for us, 50,000 programmers, ridiculous number of numbers that kind of hurt the head when you think about it. But Node went from being banned to being approved within 3 months, which is a big thing. And the good thing about going to any new solution is there are fewer controls around it in a big company. So releasing software in most places is an effort and pain and stress and yak shaving. In a big company that's heavily regulated, you're there with your shears for about 6 months trying to release something. So because this is new, it has fewer controls in place, which is good. You know, and as I think Dan said earlier, his lawyers have had heart attacks trying to say, 100 modules, please, no. So this is where we are right now. And we have a really good internal community as well, and it kind of echoes the outside world. So we can go to and get help. Now, we run into problems that for us to set up our own internal NPM is a bit of a hurdle, but we're getting there. We're getting there. I chose Happy, and I had two really good reasons to do it, two conversations. One's with Adam Baldwin and the other's with Owen Brazel. And Adam kind of steered me towards them initially, and he said, you know, Walmart has really good success with Happy and Node. And Owen said, yeah, Node's pretty good. Happy's, yeah, good. So based on that, and not only that, but primarily based on that, went off and evaluated Happy for what we were doing. And I compared it to Express. Now, this wasn't a remarkably formal exercise, but it was enough. Don't worry too much about the detail, but this is what an enterprise mobile app looks like. You got your mobile stuff at the bottom. Your arrows are how you get into the application. And you've got security on your left. You've got your application services, which could be brand new applications that are microservice based, or they could be old-fashioned SOA-based applications, or they could be simple API layers in front of mainframe monoliths or file interfaces. And on your right, we've got our infrastructure services to support our mobile development, and everything links back. Security is a big thing for us. You know, everything from data as well as authentication and authorization. So we've got to think about these things. The other thing is we've got a lot of systems out there. We've got you know, in every language you can imagine. Whenever software vendors talk to us, they say, so do you support X or Y? The answer is we support X and Y. And we don't have the luxury or the option to turn around to people and say, we have 10,000 applications, let's now all convert them to Golden Hammer number 5. So we have to support a rapidly changing world, but live within an existing one. That should have been hidden. So this is the grand evil plan, and I hope to implement this over time. But how we see Node fitting into this is the blue box in the top right. It's interacting with mobile, sensors, security systems, all this thing, the physical world, and bridging into our enterprise stuff in the bottom right. And that middle stuff is what we're looking to do. We want to do things like something as boring as booking meeting rooms using proximity services, doing internal mapping around buildings, trying to find someone. I mean, you know, where are you? Not in a philosophical sense. Well, I guess philosophically, no. I don't think it's appropriate for the workplace, but, and then, so we need to censor up the building and censor up the environment, allow payments to happen, allow people to access secure areas, pick up secure printing stuff. Printing's a big thing. We've got a vault in our basement in Dublin that has iris scanners, which is really cool. So in order to support that, we're beginning development on things like eventing engines, access services, printing services, and that's to access the magical world of the enterprise and the ride, as well as having our own systems. So that's kind of the plan. What we did is this, right? So the first part was just a simple, well, it's not that simple, but it's a reverse proxy, if you like, to allow us access back into our internal websites and resources over this thing we're calling a secure browser. The blue box again on the right is there. So we have a gateway appliance which does the SSL termination that Jeff mentioned and does some additional security checks. We use OAuth 2 to get in. The gateway appliance calls into our proxy, so we know who you are coming in, so we can start doing things. And then we fetch pages on your behalf or resources on your behalf and bundle them up and send them back to your handset or device. But it wasn't easy because we came to Node kind of new. So there's me, and my job unfortunately doesn't mean I can spend 8 hours a day coding. We have a team with varying skill levels. mainly from the OO world, Java, C#, lots of Ruby. No assembly language. People don't know assembly anymore. Terrible, but there you go. So what makes happy easy is it's just one line of code, the famous one line of code that you need. The rest we have here is about setting up logging and allowing instrumentation to happen when things fail, which is really cool, right? It's quite straightforward. It's reasonably performant. It allows us to iterate quickly, because I think it was said earlier in two of the previous talks, we know what we want to do, but we don't know down to the nth detail of what we're doing. However, we do know we need to do something like this. So what's the flow and how does it work? So you've got a mobile handset here, you've got a web resource here, how do you connect the two? So we're going to cover briefly the protocol, a little bit around the gateway access, and federated identity is interesting, right? So I call it federated identity my foot. We have federated identity internally, but we seem to log in a lot. And so this is like, you know, when you go into Gmail, after 2 days of not logging in, they keep asking you for your password, and you're saying, why? We need to do that about 3 times a day, which is much better than it was 5 years ago when we had to do it every hour. So it's a bit better. So one part of what we need to do is integrate with Windows and SharePoint. Ntlm has a specific dance it does for authentication. We covered it in detail in the Dublin Node talk, and I think you can see those online. We're not going to cover too much detail here because one of the guys, Kieran, worked on that. He knows the detail. I always want to strangle Microsoft when I see the protocol they use for that authentication. It's a 3-step protocol with like 9 messages being exchanged. It's amazingly large. So this is what we did, right? So this is what you need to do. So you're saying, I want to access this URL. I'm using this HTTP method. I'm setting a timeout, setting some meta information, usual HTTP headers, and then we're doing some log information to be sent across, and then the body to be sent across. So this is straightforward get, so there's no body, but with Pulse we do that. We send encrypted base64 across, so it can't be overly interfered with. What we get back from the proxy, again, is straightforward. It's the response body, the HTTP code, how long it took to execute. So we want to gather timing information as this works, all the headers that came back, and just the sort of response message. So again, nothing major here, but it took us a while to get up to this level. This is how Ntlm authentication works. I mean, is this interesting? You guys ever have to deal with this sort of world of specific? Right, move on. I could cover it, right? If you're interested, we could cover it. So we have lots of rules, right? This is what we got working. This is what our challenges are. We can't store passwords on devices because, you know, a lot of our users have access to very sensitive data. We don't want that pre-cached, right? And for obvious reasons. Persistent connections aren't available. You're on a mobile at a conference in Waterford. You don't have a persistent connection, certainly if you're using the Waterford Castle Wi-Fi. We have lots of latency issues. So every web resource required 3 requests, especially with Ntlm, where it got up to 9. It was crazy. So we've been doing some things to deal with the Ntlm. We ported the Java stuff, and I'll skip the rest of it because it's Ntlm specific. So now this is interesting. This slide and the first slide are from an episode of Seinfeld where Kramer goes up to Seinfeld and says, I've got an idea for us to make millions of dollars. We'll sell these pirate t-shirts. And this is him saying, I don't want to be a pirate. We use Flood for this. Flood's really cool. It allows you in a command line to specify your rate of requests, number of clients, and your ramp on how to get there. So what you're saying to Flood is I want 2,000 requests, timeout of 1,500 milliseconds, and I want you to go from 100 to 1,000 in your batch sizes. And then off you go. And you go off over here. This is a simulated one where on EC2, I was hitting a lorem ipsum 6K page. It wasn't quite 6, it was 6K and a bit, which is hence the 6K-ish. I figured once you're in 6K, that's good enough to figure it out. You don't need the extra couple hundred bytes. And just to compare it via Nginx directly, and the results are pretty good, right? I mean, they're not amazing, but you're talking at about 500 requests per second on a large instance at the time. 430 milliseconds latency versus 970. So it is double, but you can do that by not allowing 500 requests, maybe maintaining about 200, and working in that because you're I/O bound, not processor bound in this scenario. We modified Flood a little bit, not in a nice way, so we couldn't contribute it back, just to add decorated response and timing information. And we are figuring out a way to contribute it back to the main line. I went earlier this week, I saw it was tombstones, but hopefully we'll be able to untombstone it. This is the environment we ran it in. We have our own internal integration server, and it's a Red Hat 6.4 instance. And this actually speaks to the plurality of Node, right? Our production system is a Windows Server 2008 or something. Integration server, or our dev server, is Red Hat, and our development machines are Mac Minis, right? So it's really cool, right? We've got ample cores and memory for what we're doing. Keep Alive proved difficult to turn on. It's a problem with the gateway device we're using. We're using Node and Happy, as I say, and Objective-C is the client. So this is what we ran, and the results are interesting. And the results kind of speak more to, I think, our infrastructure and less to Node, but there is a little bit of Node interesting bits in there. On a direct Mac-to-Mac connection, at 1,000 requests per second, we were seeing about a 2-second latency. On a client on Red Hat, talking back to itself through loopback, we were seeing 8.5 seconds. So this is within our virtual machine infrastructure. On our client, talking to our production server, and went up to 30 seconds, which is, it's a big number for one request. Just, what you're trying to aim for in a single HTTP response time is under 500 milliseconds in a real world where life is good. What's acceptable? You might get away with 2 seconds, maybe. 30 seconds, people will start considering life options. And when we went and connected via the iOS devices, all external networks, we couldn't even get up to 1,000 requests per second. At 100 requests per second, we were at 17 seconds. So it's interesting because we were surprised at these results because this doesn't speak of Node or anything. It speaks to resource management internally. And these are the sort of things that can kind of surprise you when you're trying to implement solutions in places, that it's not down to the core technology. Sometimes the infrastructure will get you. We did some further investigation, and we plotted the time and measured the time to invoke the downstream server. It was always the same server downstream, a static HTML page. And it's about 20 milliseconds on the Mac and about 250 milliseconds on the production-like environment. Our gateway service is only adding 50 milliseconds, so it's a statistical blip. But we need to kind of look at a little bit of how we're dealing with our concurrency and request servicing. But the infrastructure is doing something. And it seems to be doing something, not just in the compute infrastructure, but also the network side of it. And I don't know, because if it's all JavaScript or something, God knows what it's doing. These are the 3 results. So we have Red Hat to Windows is the green line. The red line is just the Red Hat loopback. And the really nice line at the bottom is just the Mac developer machines. We used Excel to graph this. So as you know, whenever you see an Excel graph, don't trust it. It does things like this to make it look nice. But the main thing to look at, kind of skip anything prior to 500 milliseconds. I did this really cool result, right? So these are bar things I use for stock trading, and I used it for latency stuff. The top of the lines are the 99th percentile measurements. The top of the bar on each line is the maximum, and the bottom line is the minimum time taken for the requests. So, in a real world, you would not want to see too much banding of that, but you do see banding. So where you see banding, you need to go in and see what the distribution of request servicing times are, so you can improve your deployment of it. So at 1,000 requests per second, our bands are quite large, but they actually start kicking in at around 500-600 requests per second. So you need to go into that. Does that make sense? Is it really boring? Yeah. I know I'm between you and lunch, so ish. I think there's one more after. On the network itself, that banding gets more severe, as you see. We had this interesting result. 300 requests per second seemed to be this magic number where things worked really well, and then they got slow again. And it just really weird how it did that. So we're still, this is a great sort of science project for us to go down and pick away at the CRUD and see what's doing it. Sorry, the secure infrastructure. But these are our operational challenges. It's kind of like what you got to deal with. But overall, the experience is excellent. And we're finding things like enterprise and legal approvals are proving a little bit difficult. But with Node, you're kind of welcoming the new system architectures. And things are changing to address that, both from an organizational and data center point of view. And we're seeing that happen. So why that matters is, I guess, if any of you are in consulting or dealing with larger companies or work for them, you kind of have to appreciate that internal approvals and buy-in is important. Whether you're making the decision or bringing people along with you. And these things can come along with that. It's interesting, we're a little bit ahead of our current operations, so we're talking with them on what the best way of doing these things are. And you have really interesting conversations, because some of the reason why these processes are so slow is the virtual machines are allocated on hardware that's over capacity, clearly, right? Or I think. And you just got to work through it with them to see how to get there. The other side of it, some of the bits of nodes, we've seen it mature a lot over the last few releases. I think Jeff made the point, don't use it entirely for all your security things, but we have like certain requirements that we have to run all our HTTP endpoints as HTTPS. We just do. And then we need to have certificates which need passwords, and because it's a scripted language, the passwords are sitting there in the open. And that causes us problems, because our security people say, no, you can't have passwords in the open. And you end up doing these interesting dances, and we're trying to figure out how to get around that. But these sort of little bits and pieces. But we've learned a lot. Like, we're actively going back, refactoring the pieces we've done, trying to make it more native to Node. Some of the learnings that were up earlier, the 9 lessons, we certainly were egregious on 3 of them, I'll admit publicly. Maybe not all 9, because we don't have our own internal Node NPM. But the teams enjoyed it a lot. And the interesting thing is, we had a couple of other services we had to bring up, and they said, we don't want to do it in Ruby, we want to do it in Node. And that's really good, right? So it's something. The other thing is, we're working on getting auto scalability around virtual machines, elastic scale with it, sitting in HA proxy in front of it, and hopefully we'll get there. Because when I've been experimenting with this stuff off network, elastic environments help a lot. If you're just doing one thing, it's okay, but we're going to be doing 2 or 3 things around it, so it's going to help. And Aaron Hammer's post on best practice that they did in Walmart last Thanksgiving, Black Friday, is immeasurably helpful. So, thank you.